Welcome back on a Saturday afternoon around 1:30 p.m. It's quite hot outside, and I just came. No, today I'm not gonna fix anything, but I've came to explain a few things. You know, a lot of people, they are coming to me. You can teach me how to fix phones, teach me how to fix TVs, teach me how to fix laptops. So, and I always tell them the best way is to do it by your own self. No one is going to teach you much better except to do it by your own, practical things. So I came. It's quite quiet, the business is too low, so we can afford to explain few things about laptop motherboards, what really happened about the power sequence on laptop motherboards. So I will explain everything about laptop motherboards. So I have few motherboards here, which I have. That's a motherboard, and I think it's an Acer motherboard. So on this motherboard we have the charging port. That's the charging port. And what do we have? That's the PCH chipset. We have these coils, coil. They represent some power supplies, and we have that's the fan and the heat sink. Underneath the heat sink, that's where we have our processor. I can't see the graphic chip, so I suppose this is the kind of processor with the graphics inside. Okay. Here we do have some RAM sockets. On the other side, that's the place meant to be the BIOS battery, but it's missing. Here we have, you can see ENE, that's our microcontroller startup chip, and here we have the BIOS chip. The only easy way to identify the BIOS chip is it's a chip which is bigger than the normal size of Mosfets. You can see the Mosfets here, they are smaller, but this one is bigger. That's our BIOS chip. Okay. So here we have some coils. You can see two coils. The capacitors probably on the output. Here we have Mosfets. Two like 4, and here we have an inductor on the main voltage power rail on the 19 volts. We can see these ones, capacitors. These are ceramic capacitors. They are connected on the main 19 volts power rail. So let's take another one. We have another one. This is for some HP laptops, I can guess. That's the fan, heat sink, the processor, all in one with the graphics inside. That's the RAM socket, the battery connector. Here, that's the connector for the Wi-Fi card. You can see the input. That's the connector for the charging port. And after that, we have two Mosfets. After the two Mosfets, we have the current sensor. And from this point, our 19 volts is going everywhere. You can see some coils, more coils. And here we have our PCH. And it's got a crack on top. I think that's the reason why this board was replaced. This PCH is gone. Okay. On the other side, we have ITE. That's our microcontroller. You can see this one. And here we do have a BIOS chip. I don't know if this BIOS chip is for this for this ITE chip or is for the PCH. We have some ports for the audio thing, some USB, HDMI, nothing complicated. We have another one. This one we still have a RAM on socket. Okay, that's nice. That's the RAM. That's the BIOS battery. That's the heatsink, no fan. And we have some kind of all-in-one processor. Under this processor, that we have the PCH and the graphics inside of the processor. In most cases, the PCH is getting shorted. Okay, we have some coils, and the ENE. That's our ENE. Where's our BIOS chip? I can see here we have one BIOS chip, and here it's a place for another BIOS chip. But I don't think this BIOS chip is for the ENE. Or it is maybe. We are not testing today. I'm just explaining few things. There's some connectors for the keyboard, for the switch, for the screen connector. Okay. We have another one. That's the fan. We have the processor. I think this is some kind of Samsung laptop. RV519, I guess. Maybe. We have fan, heatsink. Under the heatsink, we have that's the processor. Graphic chip is also on heatsink. Okay, nice design. That's the PCH. Some coils. We have SMSC. That's the microcontroller. Okay. And here we do have our BIOS chip. That's the BIOS chip. So that's all about laptop motherboards. So let's do some theory. 1 second. I think we can afford to explain few things. I just want to draw few things to explain out few things if we can. Paint. Let's go on Paint. Let's open a new page here. So let's start from the charging port. I think that's a good point to start from the input. So what do you have here? We have, that's the minus of the charging port, which is going to the ground. And on the plus, we have 19 volts. That's the plus of the charging port, and the minus, and we have some center pins which are probably going to the microcontroller to identify the charging current. That's the middle pin. Let's call it MP. And on the plus, let's ignore the minus. Let's try to follow where our plus is going. From the 19 volts, which is coming on our charger. So after this, we have the first Mosfet. That's our first Mosfet. 4 pins together. And on the output, we have 3 pins together. And we have gate. Let's leave our gate like this. That's our gate. Let's call it this MOSFET M1. That's our first MOSFET. A MOSFET is just a switch. There's nothing complicated. So it's just a switch, nothing special. So our 19 volts is passing through this first MOSFET. On the output, here we do have 4 pins together. That is drain, and 3 pins together. That's our source. That's the configuration for MOSFET. We have 4 pins together, which is drain, 3 pins source, and 1 pin together, which is the gate. And after that, we have our second MOSFET, 3 pins together. Let's draw it like this. 4 pins together on the output, and here we have our gate. That's another gate for the second MOSFET, and 3 pins together. That's another source. Let's call this one M2, M to the power 2. Okay, it's also a switch, nothing special. It's just passing the 19 volts from the charging port. After the second MOSFET, we do have our, mostly it's around 7 to 10 ohms resistor, current sensor, but it's just a resistor. These days they are calling it current sensor. Let's say 10 ohms. 10 ohms. Let me do it nicely. Paint 10 ohms. Okay. So our 19 volts is coming from here through first MOSFET, second MOSFET, and then current sensor. The current sensor is there to determine the charging current, the input voltage. Actually, if anything is wrong, it will send signal to the charging IC to cut down the power. So from this point, our 19 volts is going everywhere. It's going everywhere from this point. So let's continue from this point. Our 19 volts, what do we have? We have some ceramic capacitors which are connected. One side is connected to plus and one side is connected to ground. Okay. And we have another ceramic capacitor which is connected to ground. Here can be 2, can be 3, can be 4. That's not important. We can draw one more here. Those capacitors connected to ground. Okay. Ceramic capacitors, let's call it CC. After this point, we have, let's wrap this a little bit, draw. We have our first MOSFET. We have a MOSFET here. Now I'm on the power supply to charge the battery. That's the switching power supply to charge the battery. On these days, we have a switching power supply to charge the battery. So 4 pins together. That's our drain. And then 3 pins together. Here we have our second MOSFET. 3 pins together, they are connected together. Here 4 pins together, which are going to ground. After that, what do we have here? We do have our charging IC. That's the charging IC, which is coming. Our gate is coming to the charging IC. The gate of another Mosfet is also coming here. And this gate on the input circuit is also coming to the charging IC, and this one is also connected to the charging IC. And from this point of the current sensor, our 19 volts is connected to, before the current sensor is connected to the charging IC, and after is also connected to the charging IC. If anything happen here, if we have a short on the motherboard or anything, this current sensor will send signal to the charging IC to cut down the power. That's why if we have short, if you check here from the output of the second Mosfet to ground, if there's any short, you will see it here because of this current sensor. So going forward, from the charging IC, we have the output. We are going to the output of the power supply. That's our coil. That's our coil. Let's call it a C. After that, what we have the output capacitor. Let's draw our output capacitor, which is here is ground. That's our capacitor, here is plus. So on the plus, after the capacitor, we have the battery connector. That's B plus. Let's call it B plus and B minus. That's the battery connector, minus and plus. And some charging ID pins on the connector. So here we have also current sensor. We have our current sensor here, and this current sensor is there to determine what is happening on the output of the battery charging circuit. If there's anything with over voltage, under voltage, it will cut down the power. So that's the switching power supply to charge the battery. On the plus, the power from the battery is coming from this angle. From here, it's going here. Mostly we have one Mosfet, 4 pins together, and the 3 pins together. And our gate is also jumping and go to the charging IC. And from here, it's going to this point. That's the power from the battery. It's going this way. And to charge the battery is going this way and charge the battery. So that's how things works on laptop motherboards. That's the input circuit from the charging port to the battery. So from this point, we have the charging circuit here. And what do we have also? Let's go down a bit. From this, from the main 19 volts power rail, that's our VCC point. We have the 19 volts is going everywhere. It's going everywhere. We have the 3.3 volts. 3.3 volts. Here, what do we have? We have 3.3, that's for the probably microcontroller. We have 1.5 volts, that's for the RAM. What do we have also? We have 5 volts. 5 volts for the hard drive. Also for the USB. We have a, what else do we have? We have 1 volt. 1 volt, 1.2 for the processor in the graphic chip. So here, when you find your laptop is not turning on, the first thing, you check the 19 volts. If your 19 volts is passing from this point to the current sensor and to all these power supplies, because on these power supplies, on the input, the configuration is just the same. We do have ceramic capacitors on the input and some Mosfets and the power, the controller of the power supply, and on the output we have 1.5, 5 volts depending on the kind of power supply. So what I want to talk next, I want to focus on the major power supplies. That's the 19 volts, and I will go on 3.3 because in most cases we are facing problem with this power supply. 3.3 is missing, either from the microcontroller or from the driver itself. So let's focus on the 3.3 power rail. What I would do on the 3.3, let's draw our microcontroller here. That's our microcontroller. Super I/O chip. So our Super I/O is getting power from the 3.3 volts power rail from here. Here we have 4 outputs. We have 4 outputs, and I will show you because I have some motherboards here. So we can check if we can. Let me take this Acer. This is from experience, so I'm not going to test anything, but I will just show you where the 3.3 and 5 volts is. You can see these two coils. These capacitors are on the output, so we have either this one is 3.3, this one is 5 volts, and that's the driver. That's the driver for this power supply. You can see those two MOSFETs like 4, because these are 2 power supply joined together. And we have this those ceramic capacitors. These ones are here. Those are the ceramic capacitors. They are connected on the main 19 volts power rail. After that, we have the driver, and on the driver we have a VREC 3 and VREC 5. So this microcontroller, this one, is not taking power from the output of the 3.3, but is taking power from the VREC 3. So from the 3.3 volts from the VREC 3, our microcontroller is getting power. It's not taking power from the output of this, from the output on the capacitor, this one, but it's taking power. If we check here, if I connect this motherboard to power and I check here on the capacitors, I'm sure there's 3.3 here. So from this voltage, our microcontroller, this one ENE, is getting power. So that one is clear. Let's move forward. So that's our controller. So the 3.3 is going in here. What do we have here? We have some resistors. I'll call it R. That's our resistor. After the resistor, what do we have? On the switch side, we have some sensor, but that's not important. I'll skip that one. I'll stick to the most important thing. Here, we do have our switch. That's our switch. The other side of the switch is ground. The other side of the switch is connected to 3.3 volts. So that's our switch. So the condition for the switch to start up the laptop is to bring this 3.3, which is connected on the plus, to ground. When you press the switch, this 3.3 is going to ground and release. And at that point, your laptop will start. So I think that is clear. So that's what happened on the laptop motherboard. So here, like I said, we have many power supplies. We have 3.3, 1 volt, 1.5 power supply, 5 volts for the USB. So I want to save this. Maybe let's save this one. Let's just call BB and save it on desktop. Let's open a new sheet, new page. So let's see, like I said, we have many coils which represents power supplies. So we want to see how a switching power supply is working on a laptop. That's the next step. So here we have 19 volts, which is coming from the main volts power rail. That's our 19 volts. And we have some capacitors. I'll just draw 3, can be 3, can be 2, can be 1, can be 4. That's the plus. And here we do have minus of the capacitor. That's the plus. And here we have, they are connected to ground on the other side. So our power is going like this direction. After that, we have Mosfet 4 pins together. That's our Mosfet. Let's draw it like this. And 3 pins together. And our gate, we have another one. 3 pins together. It's connected here. And our gate, that's our gate. And our gate is going to the what can I call it? Is to the microcontroller, to the power manager. That's our power manager, the drive of the power supply. So like I said, a MOSFET is a switch. So opening and closing switch, this will happen more than 20 to 30,000 times per second. So switching on and off will create voltage on the output. That's our coil. We have a coil, that's the coil. After the coil, we We have our capacitor. That's our capacitor. Electrolyte capacitor with the plus and minus connected to ground. After that, we have our current sensor to sense what is happening on the output of the power supply, which is also connected to the chip. And from this point, we have 1.5 volts, for example. That's for the RAM voltage. That's our switching power supply. So our 19 volts is coming here the power supply is taking 19 volts from the main voltage power rail, which is 19, which is coming here. We do have some ceramic capacitors connected on the 19 volts. After that, we have two Mosfets. Can be two Mosfets. You can find different configuration here. You can find two Mosfets. You can just find the coil and the chip. And in that case, the Mosfets will be inside the chip. Or you find some dual Mosfets where there will be just one Mosfet. It's not always the case to find one Mosfet, to find the two Mosfets there. So here we have 4 pins together. That's our drain. That's the drain of the Mosfet. And the 3 pins, that's our source. And 1 pin, which is our gate here. So source, our voltage is coming from the main 19 volts power array, from drain to source. Drain to source. Okay, so we want to clear this one out because we have a channel N MOSFET, channel P MOSFET, and I heard a lot of people, they were confused. How do I see this is a channel N MOSFET? How do I see whether it's a channel N or a channel P MOSFET? So I'm going to clear that one out today. So our MOSFET is like this. Let's draw a big MOSFET. That's a MOSFET. And here we have 4 pins together. Here we have 3 pins together, and our gate, that's the gate of the MOSFET. That is our source. And that is our drain, 4 pins together. That's our MOSFET. A MOSFET is just a switch. Before, they were using transistors. Which were current controlled, and they moved from transistors to MOSFET just to save power, because these are controlled by voltage. That's the difference between a MOSFET and a transistor. On a transistor, we don't have a source, gate, and drain. On a transistor, we have a, what can I call it? We have, on a transistor, we have base, collector, and emitter. Yeah, that's the configuration for the transistor. And on MOSFET, we do have drain, source, and gate. That's very clear. I think I just clear out the confusion there. So voltage coming from drain to source. What does that mean? If our voltage is coming from drain if the drain is on the input, let's call this one input, and call our source, that's our output. Yes, source output. So if our voltage is coming from drain to source, that is a channel P MOSFET. Channel P. Channel P. And if our voltage is coming from source, to drain, source, or let us do it like this, source to drain, and then it drain. Yeah, I know it's very confusing, you know. Drain to source, and then source to drain. Want to clear this thing out because it's very confusing. Source to drain, and then drain to source. If our voltage is coming from source to drain and is coming from drain to source, which is channel P and the channel N, which one is our channel P MOSFET and channel N MOSFET? Any idea? Any idea? I know that is confusing many people, because they don't really understand channel N and channel P MOSFET. But I'll show you a trick now. On source, we have 3 pins together. On the drain, we have 4 pins together. So if 4 pins is supplying voltage to 3 pins to a lesser voltage, that is a drain to source, that's channel P. And if less is supplying more to more pins, that's channel N. That's the easy way to separate the two. Of course, if you replace a channel P MOSFET with channel N, probably your motherboard will blow up. That's not a good thing to do. So that's the only way to see this one is channel N or this one is channel P. That one is very clear. So that's how a switching power supply is working. We explain how power is going on a laptop motherboard, and I also explain how a switching power supply is working, because many people they need clarity on these things. A lot of people, they were coming to me, you know what, we don't know where to start checking, how do we diagnose how power sequence is going on laptop motherboard. I think I just cleared that one out. It's now clear. So that's how things work on laptop motherboard. That's how things work on laptop motherboard. Did I left anything? I think yeah. Let's open a new page. I need to explain few things, because I need to clear this one out. I had a lot of people, they were explaining. I think I have some batteries here, laptop batteries actually. I do have some batteries here. There were many people, they say, you know what, my battery is dead, and just take out the cells and replace the cells and charge me, you know, things like that. There's nothing like that. Let us go and see what is inside this battery. I think we can afford to play because it's quite quiet. So on the battery, what do we have? We have some cells which are connected on serial mode. Can be 3, can be 4. That is our battery. Let's call it C1, C to the power 2, C to the power 3. These are our cells connected in serial mode. So here we have minus, that's the plus of our cell. So what we have on the plus, we have MOSFETs like chips, 2 MOSFETs, same configuration like that one on the input of the laptop, 2 MOSFETs. That's the sensor. After that, we have the power manager. There's a circuit there inside the battery. That's where you see these things which I'm explaining. Let's call it M1, M to the power 2. That's our current sensor, CS, sorry. This is just a MOSFET, it's a switch actually, nothing special. These are switches, 4 pins together, 3 pins together, and our gate, 3 pins together again, and our gate. That's our gate, which is going to here. And the other gate is also going to the battery charging IC. That's the power manager. And here we have some wires connected to this. After every cell, we have some wires connected. And on the plus, that's our plus. I took plus from this side. And our plus here, what do we have here? We have the battery connector. That's the minus, and that's the plus of the battery. That's what you see inside the battery. So, if these cells are gone, or they are no longer functioning properly, this current sensor will send signal to the driver or the main chip, the controller, to cut down the power. Yeah. Even if you put a working charger or normal voltage, normal current, if this current sensor is already sent report to the power manager, that battery will never work. That's why you see message like plug in the charger, plugged in, you're not charging. And sometimes you will see the battery charging to 100%, but when you take out the charger, your laptop will shut down instantly, because this sensor is reporting these cells as faulty. So even if you take these cells and replace with new cells, there's no way you can fool this chip to bring these cells as working. I once tried to, you know, there are some cells here. I tried everything just to take out the cells and replace with some. No, that is not helpful. The chances are actually less than 5%. Less than 5%, unless if you are to replace with the whole circuit, maybe in that way. Or if you have any way how you can fool the laptop to accept a faulty battery as good, just leave the comment on my channel and I'll answer you. Just leave the comment, and maybe on my side that can also help me. But I never bring a faulty battery back to life by replacing cells. No, it doesn't work like that. So that's everything about laptop batteries. I think I explained a lot. It's now time for me to go to lunch, because many people, they are coming to me, teach us how things are working, teach us some power sequence of laptop motherboard. I always tell them I don't have time to explain, but the best way is to go to my channel, you subscribe, and in that way you try to apply theory with practice, because obviously theory without practice, obviously you will never learn anything. That's why you say people even with IT degrees, they always want to learn the practical thing, because fixing things and what you learn at school, that is another school actually of fixing things. We have to learn the practical things of doing things. So yeah, I was just explaining these few things on the theory side of laptop motherboards, and hopefully you will find this video helpful. If you are on the path of learning electronics. So yeah, just subscribe and like our videos, turn on the notification bell for future updates. We'll try to push things more and more and more, especially on the professional side, because I'm trying to let people move from the analog way of fixing things to the digital way, because I see a lot of people, they say I'm a technician, I'm fixing, but if you look on his table, you don't have even a multimeter, no DC power supply, no enough tools. You have to first put your house in order, and then you serve the public. I think that is a good style. Actually, that's my style. So I'm hungry. What can I say? Like and subscribe our videos. Subscribe, don't just view. It's not enough to view videos, because you will miss a lot of stuff. Just subscribe, and see you on the next one. Bye.